Saxon Algebra 1, Lesson 68. You guys, we are in the heart of it right now. We are learning so much great algebra that is going to be the backbone of your future math career in high school. This is really good, meaty stuff that we've been working on now. And if you're hanging in there through all of this, you've got it. This is what we're here for. And if you're still surviving, then you're doing a great job. We're getting into more and more topics that have titles like this: more on, or advanced, or complex, right? These names that suggest that we're getting deeper into a topic. Very cool. That's how you know we're making progress. 68.1. Let me show you the kind of complex fraction we're talking about. Okay, complex fractions, as you recall, are fractions that have more than one division bar. And our goal in these is to reduce them, to simplify them, so they end up with just one division bar. That's our goal. That's cool. We can do that. Remember that our goal is to always start at the bottom, and we're trying to turn the denominators into ones. Because if we can turn the denominator into a 1, it goes away, right? We can ignore it. So we start at the bottom and we work our way up, turning things into ones as we go. Our best tool for turning a denominator into a 1 is the reciprocal. We multiply it by the same fraction, only upside down, right? And that turns it into a 1. Fabulous. It's great. Now, the only problem we have in this scenario, we go to the bottom, we look at this, we go, okay, we're gonna multiply this by a reciprocal to get it to go away. Then we'll multiply the top as well. But the problem is we can't use the reciprocal unless this is one fraction put together. We can't use a reciprocal of two terms like that. That doesn't work. So what we have to do is combine them. Well, the great news is this is all ready to go, right? We can combine, quote unquote, add these fractions, negative adding, subtracting, however you want to think of it. We can combine them because the denominators match. So we can rewrite this as x minus 1 over y. And now we are ready to multiply by the reciprocal. Y over x minus 1. Now, we're going to have to multiply the top one by the same. So I'm going to write that down right away. And sometimes I draw that box there to help me remember. But now, when I multiply these two together, I see this is quantity x minus 1 times y, and this is y times quantity x minus 1. You're going to get the same thing top and bottom. It poofs, it disappears, it's great. Okay, so now we want to do the same thing to the top, and we see we have the same problem. We have to add in the top, but John set it up perfectly for us. X plus 1 over y. Now we're ready to multiply these two, and look, the y's cancel. We're multiplying, so we can cancel top and bottom. So our final answer is x plus 1 over x minus 1. Yay, correct answer. All right, now, as you may have guessed, this one was fairly easy because John gave us matching denominators. Other times we're gonna have to fix that ourselves and before we can add the fractions. I don't know if you guys know these two sisters. They're a family called the Jones family. They were part of this group. Their kids are older now. The youngest is Evie. They have 3 kids. Ellis is probably 22. Esther is probably 20, and Evie's 18. They might even be older than that by now. They are cousins with the Rice girls, with Laura and Vivian, who are also my students now. The Jones girls, Esther and Evie, I taught them all the way through as well. And Evie, the youngest one, came up with a great name for this whole thing. She called this the smush and this the flip. Smush because you have to add the fractions, flip because you multiply by the reciprocal. So she referred to this process as smushing and flipping, and I thought, That's good. That's really good. I like that name. So we're going to do the smush and flip. Okay, simplify. All right. Again, we always turn our attention to the basement. We want to turn that into a 1. Sometimes it helps to do this, just so you can see how that reciprocal is going to look. We have no smushing to do this time. We can go right to the flip. We're going to have to multiply it by 1 over 7. Okay? We're going to multiply the top by 1 over 7 as well. This is all, here's my top and bottom. I'm remembering to do it. This is all taken care of. And what I usually do is just draw a slash through it. I'll do it there too, so it looks done. That means I've turned it into a 1. It's gone. We don't have to deal with it anymore. Now, things are looking good, but look at that mess we have. We have to do some smushing up on top, don't we? So we have to pick a new denominator. This, I remember, can be written as 1 over 1. So I have to find the least common multiple of x and 1. Oh, well, that's not too hard. It's x, right? This one's good to go. That means I have to multiply him by x over x. And since I'm multiplying it by 1, that is my new fraction, right? So I can kind of squiggle that out. And when I add them, I will get x plus 1 over x. Now, this is a really easy problem, but a lot of times doing it in the context of this complex fraction makes students' head go wonky. Heads up. Don't let this confuse you. This is very basic adding rational expressions, if you will. Fractions with letters. This is basic stuff. We just combined it together. Now we're ready to multiply it. The top stays the same, and the bottom turns to 7x. That's the final answer. And in both of these cases, we've accomplished our objective of netting it down to just a single division bar. There are 5 lessons, or 5 fractions in all in this, 5 problems, is what I'm trying to say. We're at the halfway point. All right, 1 over x. Okay, we see the multiple. One of the things I try to help you guys do is know where to start, okay? When you look at a problem, how do you know what to do? When you look at a problem like this, you go, oh my gosh, look at all those division bars. That's what sticks out, right? Go to the basement right away and think of Evie. We have to smush and flip. How are we going to smush? Same way we always smush fractions. Find the least common multiple. Easy, it's x. Multiply the first fraction, which is technically 1 over 1. We multiply it by x over x. Because these are 1s to begin with, we have x over x now, right? So this smushes and becomes x minus 1 over x. Good, it's smushed. Now we're ready to flip. X over x minus 1. Notice the way I work these problems. I go across, and then when I get to the point where I'm multiplying by the reciprocal, I immediately go up. Okay? Then I check to make sure that that cancels. Yes, I did that carefully. Now, do I have to do anything to fix this before I multiply it by the reciprocal from the basement? Nope. I'm good. And so, but we can cancel those x's, right? And so my answer is 1 over x minus 1. Okay? So I'm doing this all for a reason. It's easier that way. Let's do another one. Our things that we're adding together are going to get slightly messier, but not a lot. We're going to bump it up just a little here. These problems are fun because when you first look at them, a lot of students go, there's no way in the world I can possibly do that. I have no clue. That looks really hard. But if you just remember, oh, go to the cellar, smush and flip. All right. I want to put these over a 1 right away. I don't like having floating people. You know how I feel about that. We go to the basement. We say, oh, we're going to have to make those smush. Our least common multiple is b. So we're going to have to multiply this one by b over b. Okay, so that's 4b on top, and 1 times b, I'm just going to write it like that so it's less confusing for me, right? That was, I multiplied it by b over b, and I just kind of slid it in. So now I have x plus 4b all over b. I've smushed. Now I'm ready to flip. And I'm going to write it right up here so I don't forget. Okay, there's my reciprocals, hard at work. This is all taken care of. I've successfully smushed and flipped. Now I'm ready to deal with the top. Okay, my least common multiple is going to be b again. I have to smush here. I'm going to multiply 1 over 1 by b over b, and that's going to give me b over b. I'll just write it like that. Okay, these cancel. And my final answer is a plus b over x plus 4b. Yay. Normally I would have tried to write that off in this area, right? But I gave myself so much room. Last one. I hope these make you feel smart because they should. Okay, this one. Ooh, this one's a doggy. Grace is like, I'm offended. I am not a math problem. How dare you, mother? Feed me a cookie as an apology. That's what she's saying. These exponents always trip everybody out, you guys. I know it's going to happen. Let me show you how to simplify those. When we have this multiplication, or we have the exponent, and here's a little clump, but then there's this plus sign here. That means this doesn't go all the way down to the bottom. That means that we're going to create a fraction within a fraction. Do you see how I did this? This means this goes underneath the x. This means this goes underneath the y. Isn't that weird? And then this one we could flip up, but because we have such a mess up top, let's do the same thing here. That is a really, really weird treatment, and it takes a while to get used to understanding this. You're going to see these in the homework problem and go, wait, what? Remember that if you have a plus sign, you create new fractions. You don't just send them to the bottom of the big fraction. All right, now we're ready to do our thing. We'll multiply this. There's nothing to smush, so we're flipping. I'm giving myself some room because I know this is going to need some work. So I'm going to multiply it by x over 1, x over 1. There's my reciprocal, hard at work. This cancels. Now, before I try to multiply this, I'm going to smush this. Now, this one's trickier, right? Because my least common multiple is not a and it's not b, it's ab. That means both of the fractions need some adjusting. So this one, I'm going to multiply by b over b. And this one, I'm going to multiply by a over a. Now, I wrote the b's after and the a's before. It doesn't matter. I was doing that just to have some fun. But I'm going to write them alphabetically. So it will be bx plus ay over ab. I'm multiplying it by this. And so my final answer is x times the quantity, right? Because this is a quantity. Bx plus ay all over ab. Now, some students say, but wait, don't we have to distribute this? We could distribute it if we want, or we can leave it. Distributing is neither right nor wrong. So what I recommend is when you get to this point in the problem, stop and check your answer and see if John wants you to distribute or not. And what I see is he said, oh no, you don't have to distribute. So I can double check and go, yep, that's exactly what I got. If he had distributed, I wouldn't look at the answer closely, but I would go back and quickly distribute to see if I can get the exact same as him. All right. Again, his letters are in different order here and a different order there. That's okay. As long as I have a B and an X and an A and a Y, it doesn't matter if they're in the order. All right, my students, that is lesson 68. You have had a huge week in learning new amazing algebra things. I will talk to you in the video chats, the check-ins. Farewell.